Want unbreakable ransomware protection while cutting storage costs in half or more? Myota's patented technology encrypts, shards, and spreads your data across multiple locations, guaranteeing security and recovery against cyber attacks. Try it free at myota.io. That's myota.io. Welcome back, everybody, to another episode of Data Protection Gumbo. And today I am joined by a guest, David Brooks, who is a
Hey,
cybersecurity architect. And we are on here to have a fantastic conversation around early detection of adversaries and also preventing breaches in your business and your environment as well. So, David, I'd like to welcome you to Data Protection Gumbo. How's it going today?
hey, going great. Thank you for the invite and happy to be here and super cool to have a chat with you. Yeah,
And I want to
yeah.
thank you so much for being here on the show. And right now, I'm being really unspecific here. And so I'm looking just for an unspecific answer as well. What exactly is the mission that you are on in this particular season of your life? And also, what are you doing and who are you doing it for?
I'm in a season of my life where I'm trying to be a better person, know myself a little bit better, be a better dad, be a better husband, try and balance this in a career that I enjoy, having conversations about technology problems and trying to solve that in a way that's, meaningful, effective, and creative, and maybe do this with, hopefully a way that's honest and empathetic. I think as an industry, certainly, empathy, I think we can all do a little bit better with. So that's what I'm trying
Yeah.
to do, broadly speaking, just be a net positive for the world, I suppose.
Okay. Well, we can't ask for anything better than that, right? Because there's a lot of interesting people out in the world right now. We
Oh,
definitely
me,
don't
man.
need any more jerks or other words here.
Yeah, well,
But
yeah,
let's
different
get in.
podcast.
Yeah, let's get into it here. So you are a cybersecurity architect,
Yep,
and
yep.
that is a very hot profession right now, and I'm sure you're not bored any in
Hmm.
your
Hmm.
particular day job. And
Yep.
I've still been reading news articles around the cybersecurity skills gap, and I mean, there's so many jobs out there for cybersecurity experts, and I'm not quite sure if that has yet changed in light of all the layoffs that I'm hearing across the
Hmm.
board,
Hmm.
post COVID, over hiring, and also a little bit of what AI has been doing as far as making things more efficient overall as well. But
Sure.
I want to start with Vectra
Hmm.
AI and also the problem that Vectra is trying to solve. And then let's set the context from that perspective. And then let's start diving into some of the methods and tools and best practices of how data protection gumbo listeners can better protect themselves and their organizations and their businesses.
Yeah, of course. A good question there too. I guess a couple of things I heard in there, around, what is Vector trying to solve, for the industry, and as we're faced with things like you're talking about, there's always issues with the skills gap, and how many people were short in the industry and things like this that you hear. I think what Vector is trying to solve is a problem of adversary detection across the digital enterprise effectively, whether that's an on-prem network in your data center, whether that's some kind of sprawling cloud estate. You can have really good posture, you can have really good like prevention controls in place, really well implemented. The reality is it's not going to work every time.
Hmm.
And I think, and you should be doing this. Like, don't take that as me saying, don't invest in things like MFA. Like, please do that. It's not always going to work every time. And I think this is where you find these problems of like every year you hear this big number, like adversaries spent 300 something days in these environments before they're detected. And that's a lot of time for an adversary to have at their disposal. And I think this is indicative of the SOC's challenge in detecting evidence of adversaries in an environment when they weren't alerted otherwise. And you've got a lot of work and a big hill to climb as an analyst to do that. So Vector aims to solve this by kind of applying machine learning and artificial intelligence to the problem of adversary detection across these environments. We think it's a really good tool for that cat and mouse game that you see played out over the decades of, you know, cybersecurity defenders, trying to find adversaries and some way to do that.
Okay. Got it. And when it comes to early detection of adversaries, right? We know the dark web is out there, and I'm not even sure if that is a. I know it's a real
It's
place,
all pretty
but
dark, isn't it?
yeah, I know, right? And if you don't know about it, then it's dark, right?
Yeah, right.
What are some of the common signals that businesses often overlook or dismiss because adversaries they get access and there's some dwell time, right? They're in your network, they get in, and depends on how they get in. There's so many ways that they can get into your network through phishing and vishing and whaling. I mean, so
Yeah,
many
whaling,
terms,
yeah, all kinds of different
right?
like
But
fishery related terms.
how can they be more proactive in recognizing some of these signals?
That's a good question too. I think, despite the fact that I work for a cybersecurity vendor, like, look, this is an output of a process. There's no single thing you can buy or invest in that's going to do this for you. One, you have to have the right controls in place to solve the bigger problem. I think in terms of like the industry misses or overlooks, I think if you ask like most cybersecurity teams, they would say like if we had the ability to look at it all, we would, but
Hmm.
we only have so many people and so many eyeballs and brains, and we can have machines do some of the stuff for us, but ultimately there's still a lot to look at. And I think Vectra tries to maybe simplify a problem that historically has been a tough one and an expensive one to solve, which is like looking at the network for meaningful signal. You can look
Hmm.
at signatures, which are, I guess, they had their day, but they're easy to evade now. And they have their purpose. They have their purpose for posture and just the normal blocking tackling you do as a security team, but that's not telling you anything meaningful.
Hmm.
You can start looking at PCAP, which gets very expensive.
You said PCAP?
PCAP, yeah, packet capture. So
Oh,
there's an
okay.
idea of if we can record everything that happens on a network, we'll have that to be able to crawl through and audit, and we can reference that for signs of things that we think might be important, or we have a compliance requirement that we have to use that for. But that gets very expensive because you need a whole lot of hardware, to store everything, so that can add up quickly. So I think what we're looking at is like, can we reduce this problem of network detection or detection in a cloud environment to something that becomes approachable for an analyst that elevates risk where we need to. So we're not wasting time looking at things that don't pan out to be something that's worth my time. And can I do this in a way that doesn't consume so much of an analyst's time that they can't be effective? So now we get back to that thing you were talking about before of this the talent gap we have in the industry, right?
Hmm.
If I can make that level one analyst more effective with what they have, they can do work that level one analysts need to do. They can make that decision on if they escalate or take some type of process or follow a workbook or a playbook. Sorry, they can get to that decision quicker, right? Versus having to maybe pull in someone from the tier two or tier three team, and then that person comes down and it has to help the tier one team do all this, and then before you know it, that person doesn't want to do that work anymore and then quits, and you've got to backfill. So there's like a snowball problem that can happen. And I
Hmm.
think artificial intelligence and ML, at least the way Vectra views it, is not intended to like replace the SOC analyst with a robot. It's intended to enable that SOC analyst to do a whole lot more with less.
Okay. So SOC analyst, security operations center
Mm-hmm.
analyst, right?
Yes. Sorry, it's a when I say a SOC analyst, I'm referring to someone who works inside a security operations center, which would then be in charge of monitoring an enterprise for signs of breach, security related issues that may impact the business.
Okay. And also, David, in a world where threat actors are constantly evolving, and so AI has just really given them a leg up, and
Mm-hmm.
I guess the good guys we have a leg up as well, but it was also easy to detect like what misspell words and things like that in emails, and so now they
Yeah.
can leverage AI to make sure they get that email super precise, and they can also code a little bit better as well as far as creating more efficient ways to kind of detect, I mean, to go around
Yeah. Yeah.
the detection of being found out about. Now, where do you see AI coming in as far as for the good guys, and how does Vectra leverage AI to anticipate and also detect some of these evolving threats?
Yeah. Yeah. Good question. So I think your assertion is correct. Like artificial intelligence and machine learning are technologies that are out there that adversaries are going to use. They are using it to make their own operations streamlined. And so as an organization on the other side with assets to protect, I mean, you're forced to look at this, and you really have to stay on top of what's going on out there. But yeah, you're right. I mean, cyber criminals are using this for their own goal. How does Vectra use this? Well, I think Vectra looks at machine learning and things like this as I always say like it's a tool and not an objective. Like we're not trying to say, okay, we're going to use machine learning. We are going to use artificial intelligence. If we can solve a problem without using those, or there's a better tool to solve that problem, then that's what we will use.
Mm-hmm.
Machine learning and artificial intelligence happens to be useful for a lot of things, not everything. But and even under that, there are so many different types of machine learning and types of artificial intelligence to solve specific types of problems. The point of all this is that when Vectra approaches a particular issue, let's say we're trying to find evidence or alert about evidence of an adversary in an environment, we're considering what is that adversary likely to do, similar
Mm-hmm.
to what you see in something like the MITRE ATT&CK framework that tries to enumerate all the things that adversaries might engage in across the course of their time inside a network. So we try to map to that, say, okay, well, let's say that the adversary is going to try and establish command and control, meaning I have
Mm-hmm.
access into your environment remotely, I can control it remotely, and I want to try and hide that connection. I don't want you to learn about it because you'll shut it down and I'll lose my access. This is tough to find. We have encryption. We have, proxy servers. We have things out there that are great for privacy and not so great for observability and
Mm-hmm.
detection. So you have to kind of walk this line. And the machine learning can really help here. Instead of having to look at known destinations that an adversary might be working from, like, oh, we know that this IP address on the internet is bad. And so we'll write a signature. Whenever you see that, it's bad and you can shut it down.
Mm-hmm.
But if I'm an adversary, I'll just go somewhere else you don't know about. And that detection method becomes unusable, right? Or if you don't know when I'm passing through that encrypted channel, it's hard to detect. So what Vectra does is instead of relying on knowns and unencrypted traffic to detect, we look at the nature of something. So what does the nature of network traffic look like if you're involved in command and control? What does
Mm-hmm.
the nature of network traffic look like if you're trying to start a remote process and move laterally inside an environment? And what evidence can we see by time series analysis of network packets that we could maybe use to elevate that to a SOC with some degree of certainty? So now I can do things like, hey, this connection on the network looks like someone is obfuscating a command line. It looks like the client in this communication is actually acting like the server. And we can see the timings of these packets, how big they are when they come in. We don't have to decrypt them, but we
Mm-hmm.
can make a pretty reasonable assertion now that, like, yeah, it looks like someone's actually obfuscating something over this encrypted channel. Someone should know about that,
Okay.
right?
Yeah.
And if I combine that with enough sources of signal, I can give someone really a really good thing to go look at that will make hopefully an impactful difference on their ability to respond.
Okay. So you talk about the nature. So is
Mm-hmm.
that something that's analyzed across all customers, all data, or is that completely privatized or personalized? So I'm thinking LLM, right? So
Yeah, sure.
let's say there's an
Yeah,
LLM and it's analyzing, it's consuming all this data, right? And
yeah.
then it takes that data and it learns about, what are the patterns, the heuristics and all those things are being taken into account. And then it determines, okay, out of 10 billion, right? 10 billion packets.
Mm-hmm.
We've determined that A is this, B is that, C is this. So is it more customized based on an individual's, like a one organization, like they have their own customization, or is the AI engine in this, in your, let's say it's in the cloud somewhere, right? It's running on a cloud and it's capturing information and it has the intelligence based
Yeah,
on everything in order to respond back. Is that, am I understanding
yeah.
that correctly?
Yeah, I think what you're asking is a couple of things. I think you're asking one around maybe like data privacy and how do we ensure
Okay,
that
yeah.
there's
Mm-hmm.
some level of that as we apply
Right.
artificial intelligence to these problems? Because as a business, yeah, you don't want to expose too much about yourself, you can avoid it. And then of course, like how do we use these technologies to and in pursuit of that. So I think from the start, Vectra has some pretty compelling technology in that we've intentionally tried to do this so that we don't have to rely on like batch processing in the cloud. So when we're talking about network detection, we can actually run all this machine learning and AI in your environment. It doesn't have to leave for Vectra, right?
Okay.
In fact, we could air gap it and it works the
Mm-hmm.
same. So and that has, in certain industries that's really important.
Yeah.
And that is something we can do. So we want to make sure that when our ML and AI runs, like we're not, sending that to us. It is privatized. Even things that even things that start in the cloud, like if we're looking at Intra ID or M365 as a surface to protect, obviously that telemetry starts in the cloud. It would make no difference than to pull it on prem and analyze it. Like we analyze that in the cloud because that's where it lives anyways. But things like network packets, yeah, we want to make sure we do all the machine learning and AI in your environment because one, we can do it quicker. We don't have to send it somewhere to be batch processed and then like some hours later you get a detection. We do it as close to real time as we possibly can without you having to worry that that's leaving somewhere else. Now we of course routinely, because we're dealing with machine learning models, naturally if we train one up, it's only relevant for so long, right? Before the nature of command and control changes or there's new techniques or whatever. So we have to continually retrain models, as I think any vendor who uses machine learning should be doing. So those updates come down and we can update the models that
Okay.
your sensors run without actually having to send that to us. So I
Okay.
think that's a very good distinction to make. And instead of just putting an LLM on top of noisy detections to try and find a commonality in those, instead, I think we're starting the right way by writing the correct model we were looking for.
Yeah. And why was the network packet chosen? Is that like the most,
Mhm.
because there's the seven layer, the OSI
Yeah.
model, right?
Yeah.
And you have the different layers. And so is that like the best angle in order to detect something before it happens in the network packet? I just want to understand like why is the
Sure.
network
Sure.
packet like the method to analyze in order to try to prevent something from happening?
Yeah. It reminds me of a saying I've heard thrown out there a couple of times, like PCAP or it didn't happen, right? So
Okay.
like show me the packet capture or,
Mm-hmm.
there's no evidence of it. We look at the network, I think, because it's often the source of truth. Like something that interacts with the network, like if it generates network traffic, like we can use that. Like it did that. We can see that if we have a
Mm-hmm.
record of it. Like it's kind of indisputable at that point that occurred. We do this because there are plenty of other technologies out there that look at other sources. Like there
Okay.
are
Yeah.
like EDR vendors that do endpoint detection and response, like CrowdStrike, SentinelOne, Microsoft Defender. These technologies that they have a process that runs on a laptop or a workstation or a virtual machine
Mm-hmm.
that looks at what that thing does. And that's great. But there are things in the environment that you cannot always put that program on to run. Think about a hospital that
Mm-hmm.
has blood transfusion pumps, things connected to human beings, or even just your standard office environment that has printers and IP cameras and things like this. You're not going to be able to instrument that with some type of agent or the program that runs on the thing that feeds all that rich intelligence back to CrowdStrike or SentinelOne. This is very valuable, and we should be doing this, but you just can't get that everywhere. And so when you can look at how these things interface with a network, you can look at the problem through a different lens in conjunction with those things. Like it's not that CrowdStrike or SentinelOne are telling you, or any other EDR vendor, I'm just using them as an example, are telling you things that aren't valid. They're absolutely valid. Like it's a really rich source of intelligence, but the network provides a different view. And there's things inherently that can happen on the network that maybe your endpoint detection or logging won't notice, and
Yeah.
vice versa. Like there's things if you're looking at the network we can't tell on the endpoint side. So these things are very complementary. And by looking at the network, you can provide yourself a whole lot of assurance that you're maybe able to find a security threat involving medical IoT that maybe you had no visibility into
Mm-hmm.
otherwise, as an
Yeah.
example. Yeah.
Yeah, and the reason I asked that question is because it's a layered approach, right? So defense
Yeah.
in depth, you have to protect this thing at all angles, right? So the network, and then you got the endpoints, and then you got all the virtual machines, and then you have all the actual virtual networks, and you have all these different components of an environment. And so there's not one tool that's going to say, I have this one tool that means I am super secure. No, you
Exactly.
have to have
Hmm.
so many different layers in order
Hmm.
to trap and even I just thought of honeypots for some reason, right? Which is some a lure, right, to bring someone
Yeah.
into the network to trap them for
Yeah.
some reason. But maybe one more question before we close it out as well, and I want to switch to help out let's say a college student right now who is
Hmm.
they're getting ready to graduate from college, maybe in computer science or actually it doesn't matter what the degree is because we've seen all different types of degrees get into
Yeah.
technology and end up
Yep.
making technology a career.
Yep.
What advice would you give them right now if they are
All
getting ready to graduate in May,
right,
right? What advice?
man.
And it
This
doesn't have
is,
to be cybersecurity related.
I
This is
get it.
just
Yeah.
David knowledge here.
Yeah, for sure. And these are the questions that I always like am the most self-conscious, the most nervous about because
Mm,
I do want to help people out. And I often think about it, I'm like, well, like, why do people listen to me? Like, what could I possibly tell someone? I think what I would tell somebody in 2024 in that position
25.
is, you're
We
right,
talking next
2025.
year.
Sorry.
Yeah, we
Oh
talking
man.
next
Okay.
year.
So 2025. Thank you. What I would tell somebody, especially if they're graduating maybe with they want to get into, I'm going to say cybersecurity, but I'm
Okay.
sure that my example would probably be applicable to anyone looking at a specific field, is that like don't turn your nose down on opportunities that maybe aren't exactly what you want but are tangential, right? And I'm going
Mm,
to again use cybersecurity as an example. Like let's say you're graduating and you want to be a SOC analyst or you want to be on a red team or something like this, and that's all great. But like you may not find that job right up front. But hey, maybe you can go. I think there's an opportunity maybe to join a support team, join an
mm-hmm.
IT support team that's tangential to the security team. Get to know those people, do some networking. You're going to get exposure to technology in general. You have an interest in cybersecurity, so you can always leverage that in whatever role you're in, and you can use that to network, get exposure, and then maybe transition over to that team. You can get that experience under your belt. So don't be afraid to look at jobs that maybe aren't exactly what you want but are close or tangential to that. And I would also say, like, as some critique on the cybersecurity industry as a whole, I think we could do a much better job in hiring entry level jobs that are actually entry level jobs. I think we've kind of boxed ourselves out and kind of get gate kept, what is a cybersecurity role. And I don't think that's healthy both for the applicants or for the industry. I also think that there's a lot of people out there with non-traditional backgrounds like myself that are valuable in cybersecurity. Like, why do you have to have a certain type of degree or background? Like, why aren't we looking at psychology majors
Yeah.
for some of these jobs? Like, they have really good insight on how people work and how people operate, and this is
Mm-hmm.
just as valid in cybersecurity as anything else. So
Okay.
that's my tangent on that. Yep.
Great insight there, David. I
Sure.
appreciate it. All the knowledge and wisdom and information that you've provided, just from a cybersecurity architect's perspective, that has been very helpful as well. And is there any final shout out that you would like to leave for the Gumbo listeners?
Final shout outs. I'm not going to name one specifically, but thank you to, of course, Vectra for letting me come and talk about their technology a little bit on the show.
Mm-hmm.
Thank you honestly, thank you to everyone who is in our local area here in Atlanta that we see all the time at security conferences and things like that. Like all the practitioners, like y'all are out there working on holidays and doing all the stuff that people like us maybe aren't thinking about. So thank you for like living in the trenches and doing what you do. I know it's tough, but that's why we're all here and we're all in the place we are.
Yeah, that I think, and we also have to put ourselves in the shoes that we were in the trenches at one point, because when you start, you're doing trench work, right?
You absolutely are. Yep. But that's what I think gives you a lot of perspective on what these problems are and maybe how to solve them.
Absolutely. And so, David, I really appreciate you spending some time with us today here on Data Protection Gumbo. And to all the listeners out there, please check us out on YouTube. We are there as well in dataprotectiongumbo.com. And don't forget to join the LinkedIn group that we have right now. There's about 26,000 of us there. It's called Backup and Recovery Professionals. And we're having similar conversations to the ones that we're talking about right now. So thank you again, David. And until next time.
Yeah.
All right.
Thank you. I appreciate it, Demetrius.